All right, so we are going to go ahead and finish talking about polar coordinates today. Um, all right, so in this warm-up problem, this is from AP Classroom. Right here, it says the graph indicates 4 points in the complex plane. Each complex number has polar coordinates r theta. Which of the following completes the expression for the 4 points in the polar form 5 cosine theta plus I 5 sine theta? Notice. The way that this is written, this 5 cosine theta plus I 5 sine theta, that's very similar to what we did just previously where it was r cosine theta plus I sine theta. But what's different here? Notice there's a 5 with each one of these. That's because that's the 5 from the r, and all we've done is distribute that r here. So this right here, the way this is written is no different than having 5 cosine, cosine theta plus I sine theta. So that means that my r is 5, and I need to figure out what my theta would be. Well, if I look at these points that I have right here, each one of them is 5 out, and they're on my axes. Well, so that's how I know right away that that 5 right there definitely works and corresponds with what I need for my r. But let's go ahead and see what I can figure out here. What this is saying for my multiple choice answers is that my angle, so whatever I'm putting in for theta right here, could be any one of these values that I have right here. So if I did pi over 4 plus pi over 4k, and then I'm replacing k with 1, 2, 3, and 4 as I go through, what that means that I'm going to have pi over 4 plus pi over 4, and then pi over 4 plus 2 pi over 4, then pi over 4 plus 3 pi over 4, and so on and so forth. And that's what I'm going to do on each one of these is I'm going to put that 1, 2, 3, and 4 in for the k. Now, if I have pi over 4 and I add pi over 4, that gets me right here, right? But if I add pi over 4 and I add 2 pi over 4, so 1/2, that gets me over here. That gets me at 3 pi over 4. So that's definitely not going to be it. And then if I notice right here, that's both of these, okay? The reason it's going to be both of these is because this one gets eliminated on the first one. If I have pi over 4 and I add pi over 2, because I replace this k with 1, that gets me 3 pi over 4. So I can go ahead and eliminate that. So now if I do C here, pi over 2 plus pi over 2. And that's because I'm replacing k with 1. So pi over 2 plus pi over 2 gets me right here. Okay. Now if I replace that k with 2, that gets me pi over 2 plus 2 pi over 2. So that's really pi over 2 plus pi. So that's going to get me here. Okay, so far this is working. If I put 3 in for k, that would be pi over 2 plus 3 pi over 2. So pi over 2 plus 3 pi over 2 is going to get me right here. And then pi over 2 plus 4 pi over 2. So that's pi over 2 plus 2 pi. Well, that's right here. So C, that's our answer on this one. Okay. It definitely, in my opinion, this one's pretty easy once you kind of look at it here as this 5 cosine theta plus I sine theta. Because really all you're thinking about is what you have in this theta right here. I could have 5 cosine pi over 2, 5 cosine, and let's not do cosine, let's do sis. 5 cis pi over 2, and 5 cis, and then the next one to not be this pi over 2 would be pi. 5 cis 3 pi over 2, 5 cis 2 pi. And if I notice all of these right here, that's what I get here on C. Okay? All right, so let's come down here. As it says, it will not be on the AP exam, but it is needed for calculus, primarily it's really calculus BC. So let's see what we've got here. This says that I have r cosine theta plus I sine theta. And I need to use our rule for multiplying complex numbers in trig form. So let's see what we've got here. If I do z squared, that means this is z right here. That means I'm going to do z squared would be r times r, right? And then I'm going to do cosine theta 1 plus, well, I shouldn't do theta 1. We'll do theta plus theta. Theta plus theta, and then plus I sine theta plus theta. Let's go ahead and reduce this down a little bit because we can. R times R can also be written as R squared, right? And then I have cosine theta plus theta. Well, what's x plus x? It's 2x, right? So theta plus theta is 2 theta plus I sine 2 theta. Okay. Now it says find z cubed. So doing the same exact process, I would have r times r times r. And then I would have, I'm just going to write this in sis notation, sis. And then I'd have theta plus theta plus theta. Okay. Well, what's r times r times r? How can I rewrite that? I can write that as r cubed, right? And then I get sis, and then theta plus theta plus theta, x plus x plus x is 3x. So this is 3 theta. Okay, my last little one right here to try, z to the fourth. So it'd be r times r times r times r. And then I'd have sis. And then I have theta plus theta plus theta plus theta. Oops. Sneeze a little bit here. Okay, I've got all of that. Well, r times r times r times r is r to the fourth. And then that gives me sis. And then I'm going to have these 4 thetas right here. That's just going to be 4 theta. Crazy. What this actually turns out to be right here is this is our De Moivre's theorem. I'm sorry, De Moivre's theorem. Basically what that's saying is if I have something on here that anytime I'm going to have something set up like this, and it gives me that I've got n as a positive integer, that means I have z to the n power, so a positive exponent. This is going to end up being r to the nth exponent. So whatever my exponent is here, that's whatever I'm multiplying my r by. And then I'm going to have cosine, and then it's n, so whatever that exponent is being multiplied to your angle, plus I sine n theta. Okay? So that's exactly what we have up here. If you notice here, this is to the second power. So this ends up being r to the second power. So that's r to my n. Cosine 2 theta. So this is cosine this exponent times whatever the angle is. And that's exactly what we did in all of these. Okay. So utilizing this, let's go ahead and do this right here. Nice and easy. Honestly, I find this to be extremely easy. So I've got this 5 on my exponent here, and this is already written in polar form. So that means I'm just taking this 2, and I'm taking it to the 5th power. So I have 2 to the 5th power, and then I've got cosine, and then I'm putting that 5 and multiplying it to my angle. So I have 5 times pi over 2, plus I sine 5 times pi over 2. Okay. Go ahead and simplify this down a little bit. You might know what 2 to the 5th power is. You might not, but it is 32. And then I've got cosine. 5 times pi over 2 is just 5 pi over 2 plus I sine 5 pi over 2. I'm done. Now, I can write that like this. I can also write this in that sis notation. It just makes things a little bit easier. So that's just 32 sis 5 pi over 2. Either one of those is acceptable if my directions say sis notation is acceptable, okay? If it doesn't say that sis notation is acceptable, then you need to write it out in this polar form like this, okay? Let's do number 2 here. So same exact process. My exponent is 6, so that means I'm going to be raising this to the 6th power, and I'm going to be multiplying my angle by 6. So I'm going to write this as 5 to the 6th power, and then I've got cosine 6 times 2 pi over 3 plus I sine 6 times 2 pi over 3. Like I said, you might know what 5 to the 6th power is. You might not. In fact, I'm going to just go off on a limb and say that nobody has that one necessarily memorized. Lord knows I don't. It's 15,625. And then I would have cosine 6 times 2 pi over 3. Well, 6 times 2 pi over 3 gets me 12 pi over 3. And that just reduces down to 4 pi. So I have cosine 4 pi plus I sine 4 pi. Now, I will go ahead and say it's not going to be expected that you put it as 15,625 if you don't have a calculator. If you don't have a calculator, you can absolutely leave that as 5 to the 6th power cosine 4 pi plus I sine 4 pi. Okay? So this would be my non-calculator answer that I would have. Now, if you notice right here, number 3 is a bit different, isn't it? Because this one right here is not written in polar form. This is written in complex form. If I was to take this and do this with complex form and not use the rules that I've just showed you, that would mean that I have to do square root 2 over 2, oops, hold a second, minus square root 2 over 2, and that has that I, times square root 2 over 2 minus square root 2 over 2I, times square root 2 over 2 minus square root 2 over 2I. I'd have to distribute that using box method or FOIL and do that 3 times. That would be very time consuming and you're way likely to make a lot of mistakes. So instead, what I'm going to tell you that you definitely, absolutely want to do is you want to go ahead and convert this into our complex polar form. You want this to be written in that r cosine theta, r I sine theta. So let's go ahead and figure out what that would be. I'm going to convert this interior part into polar form. So that means I need to find my r. So that's going to be the square root of 2 over 2 squared plus negative square root 2 over 2 squared. And I square root all of that. Well, let's go ahead and do this off to the side a little bit here. If I have the square root of 2 over 2 and I square that, that means that that square goes to both the numerator and the denominator. So I have the square root of 2 squared divided by 2 squared. So that gets me 2 over 4, which is just 1/2. Okay, so now here I'm going to have 1/2 plus 1/2 underneath my square root. Because negative square root 2 over 2 is going to get me positive 1/2. Don't forget, just because I have a negative number here, if I'm squaring a number, it does not matter if it's positive or negative. I will always, 100% of the time, get a positive number back. So instead, I just have 1/2 plus 1/2, which is just 1. Well, what's the square root of 1? 1. So my r is either plus or minus 1. It just kind of depends upon what the angle measure is that you would be using. Let's figure out what the angle is. So my angle here would be arctan. And then I'm going to take this y and I'm going to divide it by this x. So I have negative square root 2 over 2 divided by square root 2 over 2. That looks really ugly, but honestly, I have the same number divided by the same number. It's just one of them's negative. What's anything divided by itself? It's 1. So instead, since one of them's negative, it's just negative 1. So I have arctan negative 1. Well, arctan negative 1 is going to get me negative pi over 4. If I check and look, this this tells me if I was to plot this in the complex plane, I'd be going right for my x and down for my y. Going right and down does put me in my fourth quadrant, so this angle measure is perfectly fine. So I'm going to go ahead and write this now as my complex polar form, and that's going to be as 1 is my r. You don't have to write it, but I am for the sake of this question. And then I have cosine negative pi over 4 plus I sine negative pi over 4. And then I have this entire thing raised to this exponent of 3. So that means that I'm going to take my r value, I'm going to multiply it, well, I'm going to raise it to the same exponent as what this is. So I have 1 cubed. And then I'm going to take this angle measure and multiply it by 3. So this is cosine, and then I have 3 times negative pi over 4 plus I sine 3 times negative pi over 4. Well, that's just going to go ahead and just get me negative 3 pi over 4, isn't it? And 1 cubed, that's just 1. So this right here would be cosine negative 3 pi over 4 plus I sine negative 3 pi over 4. I could write it like that, but I'm going to tell you right now, you would not see that if this was like a multiple choice question or presented to you in some way. You wouldn't see it written like this with this 1. You would just see cosine negative 3 pi over 4 plus I sine negative 3 pi over 4. So that's how that would be presented. You could also rewrite this as your final answer as just cis negative 3 pi over 4. The cis notation is a lot easier to work with. But like I said, it's just not something that College Board would accept. So if that's something that you're doing on an AP exam, don't put it on there for pre-cal at least. I don't know about for calculus or anything, but I know for pre-cal they don't want you to write it like that. So hopefully this has made some sense of using the rule here for de Moivre's theorem to go ahead and make things a whole lot easier if you have an exponent. Convert it over into polar form and then just apply that exponent to your polar form. All right.